All right, guys, we are going to be coloring a periodic table today. There are periodic table notes that go through these colors as well, but I wanted to make sure that you colored it correctly, so I'm also going to make this video for you. Okay, we're going to start with hydrogen. Hydrogen is the exception to most rules that we're going to have in chemistry, and so we're going to color it the color of poop, the color of brown. So color hydrogen brown. Lovely. Next, we're going to color our families of the periodic table. Our first family, which is under that number 1 that we just colored hydrogen, are called the alkali metals, and we're going to color those orange. Our next family under group number 2, those are the alkaline earth metals. They are going to be purple. Okay. Now, as we click through on the PowerPoint, we get to the transition metals, and we are going to color those blue. Now, the transition metals on the PowerPoint don't have the newest elements like your periodic table does, so please color in the full block. Awesome job. Now, the rare earth elements, which are known as the lanthanoids and the actinoids, these are at the bottom of the periodic table, and we are going to color those light blue. Now, because they fit in this spot right here on the periodic table, I'm going to remind myself that that's where they go and color that light blue as well. Next, we have the metalloids. Now, these are very specific elements that zigzag down the periodic table. So for the metalloids, we want to color boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Next, on our list, we're going to color the halogens. Halogens are those group 17 elements. Group 17, this is the halogen family. Then our last family is going to be the noble gases, and they shall be green. Now, I don't like any white on my periodic tables, and so we're going to color the rest of the metals gray. So think about like aluminum's a metal, lead and tin are metals. So these that are below the metalloids are metals. Sometimes we call them basic metals. And then the rest of the non-metals, this carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium, we'll color that fun teal color. Now that is just part 1 of coloring our groups and families, and so part 2 is also to label each group and family with the number of valence electrons, a Lewis dot diagram, oxidation numbers, also adding period numbers to the left side of our periodic table. Okay, so I'm going to use different color pens, but you can choose however you would like to do those. So I'm going to start with valence electrons, and I'm going to use just a pen for those. And I'm really lazy. I'm really just going to circle the number. So 1 here refers to 1 valence electron. And I'm just going to write VE for valence electron. 2, now skip the middle. 3, 4, 5, 6, 7, 8. Except for helium. Helium only has 2 valence electrons. Everybody else in this family would have 8 valence electrons. Valence electrons tell us how many dots we need for Lewis dot diagrams. So if group 1 has 1 valence electron, I'm going to show that, and I'm going to write them below this time, just so we have space, as X. There is no element X, and just with 1 dot. 2 valence electrons, 2 dots. Again, skip the blues. We're going to go down below the boron family, and my X needs 3 dots, so 2 and then 1 on top. That might be hard to see, so I'm going to zoom in on that. 3 dots. There's our 2. Now we need 4 dots, so there's 1, 2, and then we're going to separate these into 3, 4. Okay, I'm going to scroll over. At the bottom of the nitrogen family, we have moscovium. Now my camera's getting in the way. It has 1, 2, and then 3, 4, 5 dots, 1 on each of the other sides. Group 16 gets 6 dots, 1, 2, and then 3, 4, 5. Now we have to go back and put 2 on the top. And then 7 dots, 1, 2, 3, 4, 5, back to pair, 6, 7. And then lastly, 8 dots. I'm just going to stick to the side over here so you have enough space to see it. 1, 2, 3, 4, 5, 6, 7, 8. Those what Lewis dot diagrams look like, and those represent those valence electrons that we wrote and circled at the top that we're going to label on our periodic tables are the oxidation numbers. These will become more important later, but I want to go ahead and have you practice and writing them now. So oxidation numbers are the charges that the elements want to become to satisfy the octet rule. Oct, like octopus, means 8, right? So if you have 1 valence electron, it is easier to lose 1 than to gain 7 more to get to 8. So they become a +1 oxidation number. Group 2 become +2. 3 is +3. 4 plus or minus 4. So it's not easier or not as easy to gain or lose those 4. Nitrogen has 5 valence electrons. So to lose 5, it would be silly. It only has to gain 5, 6, 7, 8. 3 more to get to 8. So if you gain electrons, you become a negative charge. So a nitrogen family has a -3 oxidation. The oxygen family is -2. The halogens are -1. And if you already have 8, you don't need an oxidation number at all. The last thing I need you to do is add the period numbers to the left side of your periodic tables. So on this left side, periods are like sentences, and we read across the periodic table. So these are our periods: 1, 2, 3, 4, 5, 6, 7. I will let you use this on your next quiz. So if you want to create a key for yourself so that you know your groups and families, that would also come in handy. Have a nice day.